Have you ever wondered what happens when elliptical galaxies collide? And more importantly, what does it mean for the ultimate fate of the universe? Welcome to our journey into the depths of space, where we explore the mesmerizing phenomenon of elliptical galaxy mergers. Before we delve into the intricacies of galaxy mergers, let's first understand what elliptical galaxies are. Picture a massive collection of stars, gas, and dust, all shaped like a flattened sphere. These are elliptical galaxies, named for their oval-like shape. Unlike spiral galaxies, which have a well-defined structure with arms spiraling out from the center, elliptical galaxies appear as smooth, glowing orbs, their stars moving in random orbits. They can vary greatly in size, from dwarf elliptical galaxies, containing only a few million stars, to giant elliptical galaxies, home to over 1 trillion celestial bodies. These galaxies are not just fascinating objects in themselves, but they also hold the keys to understanding the larger cosmos. Formed through various cosmic processes, including the collision and merger of smaller galaxies, these galaxies are fundamental to our understanding of the cosmos. Picture this: 2 colossal elliptical galaxies, each containing billions of stars gravitationally locked in a cosmic tango. These enormous celestial bodies, hurtling through the vast expanse of the cosmos, are drawn toward each other by the irresistible pull of gravity. This gravitational dance is not a gentle waltz, but a powerful, dynamic performance. As they draw closer, the galaxies begin to feel each other's gravitational influence more strongly. This force distorts their shapes, pulling and stretching them into elongated spirals. In a process known as tidal tail formation, stars at the outer edges of the galaxies are yanked from their orbits and flung into space. But this cosmic dance is not just about destruction. The gravitational forces also trigger the creation of new stars. When galaxies collide, their gas clouds smash into each other, compressing the gas and dust within them. This compression sparks the birth of new stars, their light twinkling like fireworks amidst the chaos. As the galaxies inch closer, they begin to merge, their stars whirling around in a frenzied dance. Yet despite the scale of this cosmic event, collisions between individual stars are incredibly rare. The vast distances between stars mean they can slip past each other like ships in the night. Eventually, the galaxies fully merge, their separate identities lost in a swirling mass of stars, gas, and dust. The result is a new, larger elliptical galaxy, its shape determined by the violent dance that created it. Throughout this cosmic ballet, supermassive black holes at the centers of the merging galaxies also play a crucial role. These mysterious entities, millions or even billions of times the mass of our Sun, can merge to form even larger black holes, their gravitational influence shaping the newly formed galaxy. It's a breathtaking display of cosmic ballet, shaping the very fabric of the universe. Each merger, each dance, each new star born from the chaos is part of the grand tapestry of the cosmos, a testament to the dynamic and ever-evolving nature of our universe. However, observing these celestial spectacles is no easy feat. The complexities of these cosmic phenomena are as vast as the distances that separate us from them. You see, one of the biggest challenges in observing galaxy mergers is the sheer scale of the universe. These events occur millions, if not billions, of light years away. The light from these distant events takes an incredibly long time to reach us, meaning we are essentially looking back in time when we observe them. On top of this, there are the limitations of our telescopes. Even with the most advanced technology, capturing the details of these phenomena is akin to trying to spot a grain of sand on a beach from miles away. We're not just talking about physical distance here, but also the challenge of seeing through cosmic dust and gas. Yet, despite these hurdles, scientists persist. Scientists grapple with the complexities of capturing these fleeting moments and piecing together the puzzle of galaxy mergers. Despite these challenges, astronomers have developed theories and simulations to predict the aftermath of galaxy mergers. This is where the dance of the galaxies takes a turn, leading to a grand finale that is as intriguing as it is mysterious. Let's delve into this fascinating conclusion. As the galaxies merge, their central supermassive black holes, each millions to billions times heavier than our Sun, begin to interact. These black holes are the dense remnants of massive stars, and their gravity is so strong that not even light can escape. In the heart of the newly formed galaxy, these supermassive black holes begin a spiraling dance of their own. They circle each other, drawing closer and closer, until finally they merge. This cosmic event sends gravitational waves rippling through the fabric of space-time, a phenomenon predicted by Einstein's theory of general relativity. The merger of these supermassive black holes leads to the formation of a single, even larger black hole at the center of the galaxy. But what's truly captivating is the influence this single gargantuan black hole has on the rest of the galaxy. This cosmic behemoth exerts a gravitational pull so powerful that it shapes the evolution of the entire galaxy. It controls the orbits of stars, stirs up gas and dust, and even triggers the formation of new stars. It's like the conductor of a cosmic orchestra, directing the symphony of celestial bodies within its gravitational reach. But the influence of these supermassive black holes doesn't stop at their host galaxies. Their gravitational waves ripple across the universe, subtly shaping the space-time around other galaxies and potentially influencing their evolution as well. So, by studying the aftermath of galaxy mergers, we're not just learning about individual galaxies. We're uncovering clues about the evolution of the entire universe and the role supermassive black holes play in it. These cosmic behemoths exert a gravitational influence that shapes the evolution of entire galaxies, and perhaps the fate of the universe itself. In conclusion, the study of elliptical galaxy mergers offers a glimpse into the past, present, and future of our universe. These celestial collisions are not merely distant spectacles, they are vital keys to unlocking the mysteries of our cosmos. As we've journeyed through this cosmic ballet, we've seen how these galactic encounters, despite their challenges, are instrumental in our quest for knowledge. The gravitational dance between galaxies, the birth of new stars, and the formation of supermassive black holes all play a part in the grand scheme of our universe. These phenomena are not isolated events, but interconnected pieces of a puzzle that we are yet to fully comprehend. The study of these elliptical galaxy mergers is a testament to our ceaseless curiosity and our quest to understand the intricate tapestry of the cosmos. By unraveling the mysteries of these cosmic collisions, we gain a deeper understanding of our place in the cosmos and the forces that govern its destiny. If you're fascinated by the mysteries of space, be sure to explore further resources on galaxy mergers and the fate of the universe. Dive deeper into this cosmic ballet and enrich your understanding of our cosmic home. Check out related videos for even more cosmic insights.